While NASA pushes forward with its nuclear-powered engine concepts and researchers hunt for clever orbital shortcuts to slash Mars travel time, Russian scientists say they've developed next-generation rockets that could revolutionize space exploration. Rosatom, the state's nuclear corporation, claims to have built an innovative rocket engine that can drastically reduce interplanetary travel times and could carry a crew to Mars in just 30 to 60 days. The research team says they have even developed a working prototype at its lab in Troitsk, with tests already ongoing to validate its durability. Unlike conventional rockets, which burn fuel to generate thrust, nothing burns inside the new engine. Instead, the engine operates on plasma, in which an electromagnetic field accelerates charged particles of hydrogen fuel out the back to generate thrust. This method allows for an almost total conversion of electrical energy into motion, thus maximizing efficiency. Hydrogen, used as the working fluid, is a strategic choice. Light and abundant in the universe, it allows for unmatched speeds while reducing the amount of fuel needed. This combination makes the engine particularly suited for long-duration missions. At present, a one-way travel to Mars on board a spacecraft with conventional engines can take about 8 months on average, which poses a significant risk to astronauts considering cosmic radiation exposure. However, the plasma engines reducing the duration of flights to just 1 to 2 months would make possible return missions to Mars. The Troitsk Institute in Moscow is a Russian state corporation that specializes in nuclear energy and other advanced technologies like quantum computers, wind turbines, and plasma thrusters. The Russian officials say that if everything goes according to plan, they want a flight-ready version of the engine by 2030. For the prototype developed at the Institute, engineers used a 46-foot-long vacuum chamber to simulate space conditions, precisely measuring the engine's performance. Preliminary results indicate the engine provides a specific impulse, the acceleration of hydrogen particles, of up to 100 kilometers per second and a power output of 300 kilowatts. Only 30 to 50 kilometers per second is common among other engine types. The engine also has a lifespan of over 2,400 hours, sufficient for a round trip to Mars, but because this process is energy-intensive, the engine would necessitate a robust, space-based nuclear reactor to function effectively. However, these data still need to be confirmed by extended tests and independent validation. Beyond manned missions, the engine could equip space tugs, facilitating the transport of goods between planets. The technology would make interplanetary exchanges faster and less costly, opening new economic perspectives. Its combined use with onboard nuclear power plants could also enable the exploration of distant regions of the solar system, or even venture beyond. The implications for space exploration are immense. Despite its potential, the technology remains at an early stage. Real-world testing and validation by the scientific community are essential to confirm its performance. Moreover, its integration into space missions will require technical and logistical adjustments. Whether or not Russia will actually field this unmatched plasma engine by 2030 doesn't change the fact that plasma engines are being vigorously pursued by countries around the world. The Xi'an Aerospace Propulsion Institute in China, for example, similarly states that it has developed a groundbreaking high-thrust magnetic plasma thruster, and research from Wuhan University is investigating ways to bring this technology to aircraft engines. An Italian team is also currently working with a thruster that runs on water, while NASA and other organizations continue exploring light sail concepts, which use lasers and sunlight for propulsion.